Bismillahirrahmanirrahim. Um, this is the lecture which will cover the practice questions related to the topic of capital budgeting. Uh, in the previous lecture, which was of the theory part of the capital budgeting, we covered capital budgeting techniques. The four techniques that we covered were payback period, discounted payback period, net NPV, and then IRR. So these were the four techniques that we will cover. Now in this lecture, we will be covering the practice questions related to those. So let's start with the today's lecture. Okay, so this is now the first question. Question number one, capital budgeting criteria. You must analyze two projects, X and Y. Each project cost 10,000 and the firm's weighted average cost of capital is 12%. The expected net cash flows are as follows. Now, Project X and Project Y are the two projects. Project X has a cash flow negative 10,000, means at time zero we are investing $10,000 in Project X, and then we are getting return of $6,500 at the end of year one, 3,000 at the end of year two, 3,000 at the end of year three, and 4,000 at the end of year four. For Project Y, same investment, we have investment of $10,000 at time zero. Then we are getting a return of 3,500 at the end of year one, 3,500 at the end of year two, 3,500 at the end of year three, and then 3,500 at the end of year four. So basically, the same amount of cash flow is we are getting at the end of each of the next 4 years. So you can even consider it to be an annuity, right? Because equal amount after equal interval makes a stream of payment to be annuity. And since it is happening at the end of the year, so it is a case of ordinary annuity. Okay, now calculate each project's NPV, payback, and discounted payback. So three techniques will apply here: net present value, payback, and discounted payback. Part B, which project should be accepted if they are independent, and Part C, which product should be accepted if they are mutually exclusive. So basically in Part A, we need to do the calculations, and in Part B and C, we'll be getting we have to answer based on the calculations that we did in Part A. Okay, now let's move on to the solution of this question. For calculating net present value, what we have to do is we have to sum up all the cash flows, present value of all the cash flows. Now for project X, you can see that we had a negative cash flow of $10,000. The present value of 6,500 that we are getting at the end of year one, and the rate of the weighted average cost of capital is 12%. So the formula for present value is future value. This is the value we will be getting at the end of year one, future value divided by 1 plus I. I is the rate of interest or weighted average cost of capital. So 1.12 and raised to the power n. N is the number of years. So we are getting this amount at the end of year one. So we have taken 1 here. Similarly, present value of 3,000 we are getting at the end of year two. 3,000 we are getting at the end of year three, the present value of 1,000 that we are getting at the end of year four. So we calculate the present value of all these four values and then we add all of them. So we get the net present value of $966.01 for project X. Same thing we can do here for project Y. We can calculate the present value of each of the individual cash flow, or as I told you that since we are getting equal amount at the end of each year, so we can even use the formula for present value of ordinary annuity to calculate the present value of this stream of payment. Anyway, both ways you can do that, and the result should be $630.72. So this is the in part A, we were required to calculate net present value. Then move to the next thing that we were required was payback. Now, to determine the payback, construct the cumulative cash flow for each project. So this is now in this table we are calculating the cumulative cash flows. This is the year 0, 1, 2, 3, and 4. And then project X has had a cash flow of 10,000 negative. Then uh, we are getting this is the cumulative value, so we are getting 3,000 at the end of year. For project X we are getting 6,500, so that minus 10,000 minus plus 6,500 is 3,500. Then we are getting 3,000 at the end of year 2, so minus 3,500 plus 3,000 is minus 500. Then again we are getting 3,000 at the end of year 3, so minus 500 plus 3,000 is 2,500. And at the end of year 4 we are getting 1,000, so 2,500 plus 1,000 is 3,500. So this is the cumulative cash flow for project X. Now cumulative cash flows for project Y, minus 10,000 we are getting a cash flow of 3,500 at the end of each year. So minus 10,000 plus 3,500 is minus 65. Minus 65 plus 35 is 3 minus 33,000. Minus 3,000 plus 35 is 500 positive. Now add 3,500 into it and we get 4,000. So these are the cumulative cash flows. Now payback for project X. So remember, we have to consider the last year where our cumulative cash flow is negative. So the last year where we had an cumulative cash flow, negative cash flow was 2. You can see in year 3 it is positive. So here this value is the last year in which we had a negative cash flow, cumulative cash flow. This is the last year. So 2, we put the value 2 here, plus how much amount is required to break even. This is the amount that is required, 500. So we put it here. This 500 is the amount required for break even. Then what is the cash flow we are getting in year 3? So in year 3 you can see that we are getting a cash flow of 3,000. So we put that 3,000 here. So by calculating this value, this equation, the value is 2.17 years. So this is the payback period for project X. Similarly, payback period for project Y. Again, see which is the last year where we had the negative cash flow. Now this is the last year, because in the next year we are getting a positive cash flow. So this negative cumulative cash flow, the last year where we had negative cumulative cash flow is 2. So we put 2 here. Now see, at the end of the year 2 we require 3,000 for break even. So this 3,000 is put here as a numerator in the equation. And then we see what is the cash flow in the next year. So we are getting 3,500 at the end of each year. So this 3,500 is put as a denominator here. Now calculate this value and it comes to 2.860, 86 years. Okay, so this is the payback period for each of the 2 projects. The third requirement was to calculate discounted payback. Okay, so for calculating the discounted payback, we need to construct the cumulative discounted cash flow. Here we calculated cumulative cash flow. In the discounted payback period, we'll construct the cumulative discounted cash flow. So one step is added for discounted cash flow. This is the timeline. These are the cash flows for project X. Now, present value of these cash flows. Present value at time 0 is the same. Present value at time 1, 6,500. So for calculating present value, we'll use the formula. Present value is equal to FV. This is FV divided by 1 plus I raised to the power n. 1 plus I is 1.12, n is 1. So by using that formula, we calculated this value. Similarly, the present value for the 3,000 we are getting at the end of year 2 is this. Present value for the 3,000 we are getting at the end of year 3, and then we calculated the present value of 4,000 that we are getting at the end of year 4. Okay, now cumulative discounted cash flow minus 10,000 plus 5,803. So we have to add this value. So since minus 10,000, so minus 10,000 plus 5,803.57 is minus 4,196.43. Now this plus the cash flow, discounted cash flow we are getting at the end of year 2. Minus 4,196.43 minus 2,391.58. So our next cumulative cash flow value is this. Now minus 1,804.85 plus 213.5. We have to add these two values. So it gives us 330.49. And then we have to add this with 635.52 to get this. Okay, so once we have calculated the cumulative discounted cash flow, now we can calculate the discounted payback for project X. Last year for negative cash flow, this is the last year, because you can see in year 3, the cumulative cash flow is positive. So the last year is 2. 2, we put here in the equation, plus what is the amount required, discounted cash flow amount required for break even is 1,804.85. This is the amount that is required. So we put it at numerator. And then the next discounted next discounted cash flow is 213.5434, and we put it in the denominator. So by solving this equation, the discounted payback period for project X is 2.85 years. Okay, so let's move on to the calculation of the discounted payback period for the project Y. Same thing, timeline for project Y is here. Then the cash flows are there. Then these are the discounted value, present value of these cash flows. And then we calculated the cumulative cash flow the way we calculated in the case of project X, the same way we calculated these cumulative discounted cash flows. And then now since we have all the information available, we can calculate the discounted payback for project Y. First thing is we require the value the last year where we have the negative cash flow. See, this is the last value because in the next year the cumulative cash flow is positive. So last year where we had the negative cumulative cash flow is 3. So we put 3 in the equation, plus what is the amount required for break even at the end of year 3 is this 1593.59. So we put this value in the numerator. Then what is the discounted cash flow in the next period? So this is the discounted cash flow in the next period. We put it in the denominator. When we calculate, the value is 3.72 years. Okay, so we are done with part A here. The requirement was to calculate NPV, payback period for both the projects, and discounted payback for both the projects. So we move on to the part B and C, which basically are the theory parts. Okay, now once we have calculated payback period, NPV, and discounted payback period, so all the methods, project X rank higher than project Y. Thus, since both the projects are independent projects, then in that case we can accept both the projects. Remember, independent projects are the one in which the cash flow of one project is not affected by the cash flow of the other project. If the projects are mutually exclusive, so in this case we would choose the project with the higher NPV at 12% WACC or discounted rate. So project X will be chosen if the projects are mutually exclusive. So mutually exclusive projects are where we have to choose one and we have to reject the other project. So in this case, project X will be accepted. So this is how we'll be solving question number 1. Now, since we have solved it, we can move on to next question. Okay, so this question is we don't have to solve anything. It's a theoretical or conceptual question, you can say. Project X is very risky and has an NPV of $3 million. Project Y is very safe and has an NPV of 2.5 million. They are mutually exclusive, and project risk has been properly considered in the NPV analysis. Which project should be chosen? Explain. So, considering the two scenarios, you have to choose one of these. And whichever project you choose, you have to give the justification that why you selected that project. Okay, so let's move on to the solution. Project X should be chosen or project Y. Why? Since the two projects are mutually exclusive, only one project can be accepted. The decision rule that should be used is NPV. Since project X has the higher NPV, it should be chosen. The cost of capital used in the NPV analysis appropriately includes risk. So this is the reason that why we have selected project X. As it was mentioned in the scenario that these are the mutually exclusive projects, so we have to choose only one out of the two. We can only choose one, and the criteria is NPV. So in case of mutually exclusive projects, we choose the project with the higher NPV. And as far as the risk of the projects are concerned, that risk is addressed in the cost of capital. So since that cost of corporate capital was considered in calculation of NPV, so it means that risk factor is already taken care of. So based on that, we can say that project X should be selected instead of project Y. Okay, so let's move on to the next question. Okay, this question again is a theoretical question. You don't need to you don't have to solve this question. Rather, you have to justify, you have to give the reasoning of your answer. A firm has $100 million capital budget. It is considering two projects that each cost 100 million. So project A has an IRR, internal rate of return, of 20%, an NPV of 9 million, and will be terminated after 1 year at a profit of 20 million, resulting in an immediate increase in earning per share. Okay, so this project A is a short-term project. It is only 1 year project. At the end of the 1 year, this project is going to be completed, resulting at a profit of $20 million. And the IRR of the project is internal rate of return is 20% and NPV is 9 million. Okay, now project B, which cannot be postponed, has an IRR of 30% and an NPV of 50 million. However, the firm's short-run earning per share will be reduced if it accepts project B because no revenues will be generated for several years. Project B is relatively a long-term project. It has a higher IRR and NPV compared to project A, but it will start generating revenues after several years. So in the beginning, the company has to wait. There's a little, you can say, slow period in the beginning, but after several years, the project will start generating the revenues. We have this scenario given where these two projects are there, and we have to answer the questions that should the short run effects on earning per share influence the choice between the two projects. Remember, project A is a short term project, project B is a long term project. Project B: how might situations like this influence a firm's decision to use payback? Okay, you can, think for a while to answer these questions, and then we move to the solution part to answer these questions. Okay, Let's move to the solution. Part A. Part A was, remember that should the short run effects on earning per share influence the choice between the two projects. So project A was short term, it was giving a profit of 20 million in a year, whereas project B was a long term project. So should the short run effects of earning per share influence the choice? In general, the answer is no. The objective of management should be to maximize value. And as we point out in subsequent chapters, stock values are determined by both earnings and growth. The NPV calculation automatically takes this into account. And if the NPV of a long term project exceeds that of a short term project, the higher future growth from the long term project must be more than enough to compensate for the lower earning in early years. Right? So, this is the justification for answer for part A. Now, part B. How might situations like this influence a firm's decision to use payback? Part B. If the same $100 million had been spent on a short term project, one with a faster payback, reported profits would have been higher for a period of years. This is, of course, another reason why firms sometimes use the payback period, right? So, if you are using a short term project in which the payback is faster, so we can expect that the reported profits would have been higher for a period of years. So this is the one of the motivation for the firms to use this payback period. Okay, now let's move on to the next question. Okay, the question number 4, project K. This is the project name. Cost $52,125. Its expected net cash inflows are 12,000 per year for 8 years, and its weighted average cost of capital is 12%. So what we have to calculate is that we have to calculate the project's NPV, project's payback, and project's discounted payback. So before we move on to the solution part, I would suggest you take 2 to 3 minutes and try to solve this question at your own. And then once you have solved it, we can compare with the solution, which we'll see in the next slide. So I'll give you a break. I'll give you 2 to 3 minutes to solve this question. Okay, ji, let's move to the next slide. Solution for the question number 4. So as I told you, you have to calculate the uh, NPV. So NPV, you can see here NPV, how we have calculated the NPV. Uh, these are the present value of the cash flows, right? Since we are getting uh, cash flow from year 1 to 8, 12,000 per year, this also makes it an annuity. So either you can use, since the number of years is more, you will be saved from all this labor. ठीक है ना, आप ये अलग अलग सारी कैलकुलेशन से बच सकते हैं अगर आप यहाँ पे प्रेजेंट वैल्यू ऑफ ऑर्डिनरी एनुइटी का फॉर्मूला लगा लें, तो आप ये सारी एक एक फॉर्मूले से ये सारी कैलकुलेशन कर सकते हैं। अगर आप नहीं करते तो फिर आपको ये करना पड़ेगा जो कि यहाँ पे हमने किया कि 12,000 की प्रेजेंट वैल्यू ये आ जाएगी एट द ईयर ऑफ 1, ईयर 2 की ये आ रही है, ईयर 3 की प्रेजेंट वैल्यू ये आ रही है। तो हमने इंडिविजुअली 8 ईयर्स की जो वैल्यूज आ रही थी वो कैलकुलेट कर ली। जब हमने उनको एड अप कर लिया, इन सारी वैल्यूज को एड अप कर लिया, तो हमारे पास जो है वो प्रेजेंट वैल्यू, नेट प्रेजेंट वैल्यू 7486.68 आ गई। ठीक हो गया जी। सो दिस वाज द आंसर टू द क्वेश्चन नंबर 1। नाउ part 2 was payback period. Since the cash flows are at a constant 12,000, the payback period can be calculated as 52,125 was the investment divided by 12,000. So this is 4.3438. So the payback is about 4 years. Okay, so you can calculate the shortcut method as well, since we have a constant rate of inflows. Now, discounted payback period. This is the calculation for discounted payback period. These were the cash flows. These were the discounted cash flows. And then this is the cumulative discounted cash flows. And so the formula is that we have to see the last year where we had the negative cash flow. So this is the last year because the cash flows are positive, cumulative cash flows are positive here. So this is the last year, which is the year 6. So 6 here. The amount required for break even is 2788.11. We put it at that numerator. The cumulative cash flow in the next year is the cash flow, discounted cash flow in the next year is this 5428.19. So our discounted payback period is 6.151 years. So I hope every one of you got the same answer. If not, then you can see where the mistake was, and you can correct your mistake by looking at this. Now move on to the next question. Your division is considering two projects with the following net cash flow, with the following net cash flows in millions of dollars. Project A has a initial investment of $25 million, and then you'll be getting 5 million at the end of year 1, 10 million at the end of year 2, and 17 million at the end of year 3. Project B has an initial investment of 20 million. You will be getting 10 million at the end of year 1, 9 million at the end of year 2, and 3 million at the end of year 3. What are the projects NPV assuming the WACC is 5%, 10%, and 15%? Now you have to calculate NPV by using different weighted average cost of capitals. If WACC were 5% and A, B were mutually exclusive, which would you choose? What if the WACC were 10%, 15%? So basically, you will be calculating NPV for different, uh, considering the different rates of return, WACC. So again, let's try it. I'll give you I'll pause for 2 minutes here, and then we'll come back to the solution.
Okay, Ji, now let's move to this. Let's see how what answers you got and how we can solve this question. Okay, so now I'm going a little faster here because we know how to calculate the NPV. So what we did is that we calculated the NPV by using the 5% weighted average cost of capital, and the NPV is 3.52. Now, when we change this 5% and weighted average cost of capital to 10%, NPV is 0.58. And at a weighted average cost of capital of 15%, NPV is negative 1.91. I hope you people solved and got the same answers. 5% WAC, this is the NPV, 10% WAC, the NPV is 0.58, and 15% WAC, the answer is 1.91. So these were the NPV for project A. Now project B, same way we calculated NPV at 5%, which is 2.87, NPV at 10%, which is 1.04, and NPV at 15%, which is 0.55. Okay, now let's calculate the IRR for both the projects, project A and B. If you want to consult the formula for IRR, you can go back to the lecture, previous lecture, and you will see what is the formula for WAC. I have the solution in the next slide, but before I go to the solution, I would like you to solve it. So let's see what answer you get, or whether you get the same answer that is given on there. So solve it.
Okay, Ji, let's move to the solution that how we can calculate the IRR for both project A and B. This is the IRR for project A. The formula is lower discount rate plus difference between the two discount rates multiplied by NPV at lower discount rate divided by absolute difference between the NPVs of the two discount rates. Uh, if you recall, for calculating IRR, we need two discount rates, two different rates. One discount rate at which NPV is positive and one at which NPV is negative. We have already done this in this question. We have calculated the NPV here, and we can use these two NPVs. NPV for project A at a discount rate of 10%, NPV is this positive 0.58, and a discount rate of 15%, NPV is negative 1.91. So we can use these two discount rates and these two NPVs for calculation of IRR. So NPV at 10% is 0.58, NPV at 15% weighted WACC is 1.91. Now, internal rate of return for project A, lower discount rate is 10. Difference between the two, 15 minus 10, 15 is the higher, and minus 10, 15 minus 10, multiply by NPV at lower discount rate. NPV, this is the NPV at lower discount rate, 10%, divided by NPV at lower discount rate minus absolute difference between the divided by absolute difference. So for absolute difference, minus was 0.58 minus, this was negative, so minus 1.19, 1.91. Okay, now solve this. 15 minus 10 is 5, and we solved this, we got this answer. Then 10 plus 5 multiplied by, we solved this part of the equation, it is 0.23, and then we multiplied 5 into 0.23, it is 1.16. So 10 plus 1.16, this is the IRR for project A. Now similarly, IRR for project B, we took two discount rates, 10 and 15. These were the NPVs, and the same way we calculated the IRR for project B, and the answer is 13.27% approximately. So this was the IRR for both the projects. Okay, now part C of this question, that if we consider 5% weighted average cost of capital, NPV of project A is greater than NPV of project B. Both projects are mutually exclusive, so we choose project A. At a weighted average cost of 10%, NPV of B is greater than NPV of A, so we choose project B. At a weighted average cost of capital of 15%, both NPVs are less than 0, so neither project would be chosen. That is the answer for part C of the question. So since we are done with this question, we move to the next question, question number 6. Okay, project S costs $15,000 and its expected cash flows would be $4,500 per year for 5 years. Mutually exclusive project L costs $37,500 and its expected cash flows would be $11,100 per year for 5 years. If both projects have a weighted average cost of 14%, which project would you recommend? Explain. To answer this question, we have to calculate the NPV of both the projects. So before we you can try solving this question, and we have a pause here. Okay, so uh, I hope you would have solved it. What you can do, if you want little more time for solving it, you can pause the video yourself for more time. If you want more time for solution solving this, you can pause the presentation for a longer time so that you get the answer, and then you can compare it with the solution which is given in the next slide. Okay, so what we did is we calculated the NPV for both the projects. Project S NPV, uh, again, it is cash flows for year 1 to 5 are 4500. So you can use present value of ordinary annuity formula as well. Discounted rate is discounted rate is 14%, WAC is 14%. So NPV for project S is 448.86. Similarly, cash flow for project L for 5 years it is 11,100. So same payment at the end of each year. Again, you can use the formula for present value of ordinary annuity to calculate it. Uh, Discounted rate is 14%. NPV is 607.20. The decision rule for mutually exclusive projects is to accept the project with the highest NPV. In this situation, the firm would accept project L since project NPV for project L is 607.20 compared to NPV for project S, which is 448.86. Right? So project L's NPV is greater than project S. So project L will be accepted. Why? Because it is a mutually exclusive project. So let's move on to the next question, number 7. A company has 12% weighted average cost of capital and is considering two mutually exclusive investments with the following net cash flows: Project A and Project B. Okay, so first of all, you need to calculate the NPV for each of the project. You also need to calculate IRR for both the projects. And from your answers to part A, which project would be selected if the weighted average cost of capital were 18%, which project would be selected? So again, you can pause here for a while and try to solve this. Try to solve the NPV and IRR for both the projects, and then you can compare with the slide with the answer which is given in the next slide. So let's have a pause for here for a few 2 minutes. Okay, I hope you people would have tried to solve it at your own. If you have, now we can compare it with the answers which are given in the next slide. Okay, so at 12% weighted average cost of capital, project A has the greater NPV, specifically 200.41 as compared to project B's NPV of 145.1. So this at a 12% weighted average cost of capital, we calculated NPV for project A. The project A NPV was this, whereas project B NPV was 145. Since project A's NPV is higher, we'll accept project A at 12% weighted average cost of capital. Now, for calculation of project IRR for the both projects, you have to use the same formula that we used in the previous question for IRR. IRR for project A is 18.1 and IRR for project B is 24%. Now, this is the NPV for project A and this is NPV for project B. This is IRR for project A and this is IRR for project B. The correct decision is project A should be chosen because NPV of project A is greater than NPV of project B. This part C was if we use 18% with average cost of capital, then in that case NPV of project A is 2.66, whereas NPV of project B is 63.68. So if we use 18% weighted average cost of capital, NPV of project B is greater than NPV of project A. So the project B would be chosen. Okay, so with this, we reach to the conclusion of our today's presentation. and I hope things are clear. If you need any further, if any question is not clear or if you have any problem, you can ask them, sending me email or through WhatsApp, or even you can post that question on the LMS discussion forum, and I'll try to answer those questions. So with this, I'll say goodbye to you, and hopefully the things in this lecture you have enjoyed watching this lecture. Thank you very much.